Okay. After that, isomerism. Isomerism means same molecular formula, but different structures is called as isomerism. For example, C4H10. C4H10. You can write as CH3, CH2, CH2, CH3. This one. Butane, normal butane. If you take CH3, CH, CH3, CH3. Count it. How many carbons and hydrogens are there? Here 1, 2, 3, 4 carbons, 10 hydrogens, right? Here 4 carbons, 10 hydrogens. So, same molecular formula with two different structures. This type of compounds we are calling as isomerism. This process is called as isomerism. These two are called as isomers. These two are called as isomers. Same molecular formula and different structures. Chemical reactions of organic compounds. Chemical reactions of organic compounds. If you observe, what type of reactions that takes place in number 1, combustion reaction. Combustion. We know that what is combustion? Burning in presence of oxygen. Burning in presence of oxygen is called as combustion reaction. For example, if you take hydrocarbons, especially hydrocarbons, if they are burning in presence of oxygen, they release carbon dioxide along with heat. They release carbon dioxide along with heat. For example, CH4 in presence of oxygen, if they are burning, they release CO2 plus H2O, H2O also, H2O plus heat. This is a heat releasing, so this reaction is exothermic reaction. Exothermic reaction. Now, you can understand that, you can ask that, alkenes are there, saturated compounds are there, saturated hydrocarbons and unsaturated. Saturated hydrocarbons are on combustion really burn with blue flame. They are burning with blue flame for saturated hydrocarbons. Unsaturated hydrocarbons burn with yellow color flame. If you take, we already discussed aromatic compound. Aromatic compounds release sooty flame. Sooty flame means black color ash will be released. For example, camphor, karpuram, when we are using for puja, they are releasing sooty, black color powder will be released from that flame. That is called as a sooty flame. So, aromatic compounds release the burns with the sooty flame, unsaturated yellow flame and saturated blue color. Whatever it may be, they release carbon dioxide along with water, heat. So, this is exothermic reaction. I hope you understand. After that, second one, oxidation. What is meant by oxidation? Oxidation means addition of oxygen or removal of hydrogen. For example, if you take CH3, CH2, OH, ethyl alcohol, ethanol, on oxidation with KMnO4, it is good oxidizing agent. It means it gives the oxygens. So, by adding oxygens, it is converting to aldehyde. Means here we remove the hydrogen, so it is oxidation. Again, if you are doing the oxidation, KMnO4, CH3, COOH, again one oxygen is added. So addition of oxygen and removal of, here removal of hydrogen takes place, so that is oxidation. Here addition of oxygen takes place, that is also oxidation. So organic compounds generally they involve in oxidation. After that, addition reaction, especially this addition reaction takes place in multiple bonds, means which is having double bond and triple bond. It does not take place in even in single bond reactions, does not take place. So double bond and triple bond is there, means addition reaction easily takes place. For example, C double bond C, CH2 double bond CH2. If you want to add H2, if you are in presence of nickel, platinum or palladium, any metal you can take. In these three, any one metal. Addition of hydrogen takes place. So CH3 bond CH3 means unsaturated compound converting into saturated compound. Even though this reaction takes place, unsaturated oils undergoes for hydrogenation. Addition of hydrogen takes place, addition reaction, converting to the saturated oils. This is called as addition reaction. The total molecule is adding on that. Or otherwise, this is also CH2 double bond CH2. If you are adding HCl, we will get CH2, one side hydrogen, one side chlorine will be added. So addition of this molecule takes place on double bond. So it is called as addition reaction. Substitution reaction. I think 4. Substitution reaction. What is meant by substitution? For example, CH3 CH4 is there, means 4 hydrogens, has to remember. When reacts with chlorine in presence of sunlight, we will get CH3Cl plus HCl. What happened? One chlorine is substituted in place of hydrogen. That is called a substituent reaction. If you add one more chlorine to this, here CH2Cl2. What happened here? One hydrogen replaced by chlorine. Again, if you want to add chlorine to this, you will get CHCl3. This is chloroform, what we are using for anesthesia, CHCl3. Again, if you add chlorine, in every case HCl will be removed. HCl. CCl4, carbon tetrachloride will be formed. Means all hydrogens are replaced by chlorine. Means chlorine is substituted in place of hydrogen. So this is example for substitution reaction. Esterification. Esterification means formation of ester. Formation of ester. What is ester? COO group. COO group. When CH3 COOH when reacts with C2H5OH. C2H5OH. From here H, here OH will go out. We will get CH3 COO C2H5. CH3 in presence of concentrated H2SO4. Means we are removing the water from 2 molecules. So this is called as a dehydration. Dehydration means removal of water. In our body also dehydration takes place, means water is removing. Dehydration. Here concentrated H2SO4 is good dehydrating agent. It can remove the water. So from these 2 molecules water will be removed. We will get, this is ester formation. So ester formation is called as esterification. After that, suppose reverse of what? Esterification. Esterification means, for example, CH3 COO C2H5 we are taking. reacts with NaOH. Reacts with NaOH, we will get CH3COONA means sodium salts of carboxylic acid and C2H5OH. C2H5OH. This reaction is called as saponification. What is a soap? Soap is a fatty soap. Soap. What is soap? Soap is fatty acids of sodium or potassium salts of carboxylic acid. Fatty acid of sodium or potassium salts. C17, H35, COONA is the formula of soap. Formula of soap. We are going to discuss now. Number 1, ethanol. Ethanol. Ethanol, what is the formula? Eth means C2H5OH is called as ethanol. This is also called as ethyl alcohol. This is common name, this is IUPAC name, that is the difference. How to prepare this one? So many methods are there, we will discuss only one method. When CH2 double bond CH2 reacts with water. What is this? Alkene. Alkene means ethene. When reacts with water, we will get CH3 CH2OH. CH3 CH2OH. And alcohol. What are the properties of alcohols? Alcohols are poisonous in nature. These are poisonous in nature, so that it is not good for health. Poisonous in nature except ethyl alcohol. Ethyl alcohol is not poisonous, but it is dangerous to the health. And these are more alcohol, more OH groups are there in one compound, it causes heart attacks. More OH groups are there means if we are taking more OH group contained compounds also causes heart attack. And what is the reaction of alcohols? Alcohols are acidic in nature. How can we say alcohols are acidic in nature? When it reacts with metals, they release CH3 CH2ONA plus H2 gas. Who are releasing hydrogen? They are called as acids. So these are acidic in nature. That is about ethyl alcohol. And ethanoic acid. Ethanoic acid. What is ethanoic acid? Eth, 2 carbon, CH3, COOH. Oic acid means COOH group with 2 carbon. Ethanoic acid. The general name of this one is very famous with acetic acid. Acetic acid. It is a weak acid. We already discussed in acid bases. Acetic acid, which is present in vinegar. Right. Now, how to prepare ethanoic acid? CH3CN. CN is there means cyano group. Methyl cyanide. When hydrolysis, addition of water we are taking, we will get CH3COOH. CH3COOH by releasing NH3. NH3 will be released, right? Now, what are the properties of acetic acid? Acid, in its name it is there, it is acidic in nature. Means, how can you say? CH3COOH reacts with Na, they release CH3COONA plus H2. Means I am not balancing. Here you need to take 2. Right. H2 gas it is releasing. Who are releasing the H plus ion? That is acidic in nature. Not only like that, CH3COOH when reacts with Na2CO3 and NaHCO3. Na2CO3 and NaHCO3, it form CH3COONA plus H2 plus CO2 gas. Here also CH3COO plus H2 plus CO2 plus CO2 they are releasing. Who are releasing means acid also we said as acidic in nature, even though carboxylic acid. Carboxylic acid is a strong acid. Carboxylic acid is more acidic. Carboxylic acid more acidic than alcohol. How can you say? How can you say means these two are basic in nature. Na2CO3 and NaHCO3 are basic salts. Basic salts, these are not react with alcohol, means that much acidity is not there for alcohols, but they are react with acetic acid, they release the H2 gas. So carboxylic acids are more acidic than alcohol. Acidic than alcohol means they are having pKa value. What is pKa? pH is there, we already calculated pH, minus log H plus ion, minus log H plus ion. Like that, pKa value is there for acids. This is acid's strength, acid strength. If pKa is value is more, acidic is less. Acidic nature is less. You have to remember which is having more pKa value, their acidic nature will be less. What is the reason? pKa means a log of Ka. Log of Ka. Negative is there. So which is having pKa value is more, due to the negative, less acidic. So Ka value is more. Ka means some value is there, no? Ka value is more means more acidic. More acidic. pKa value is more means less acidic. That is the pKa value. After that, micelle formation. Micelle. Micelle formation means using of soap and detergent. Soap and detergent. What we are doing? Detergent, right? We said that C17H35 COO Na is called as a soap. If you observe, this is just like as COO minus Na plus. Here these all are carbons. How many carbons? 17 carbons like this. These are two ends are there. One is a sodium end, one is what is this end? This end is called as what is that? Carbon end. Carbon end. This end is hydrophobic end. Hydrophobic end, because ions are there, this is hydrophobic end. This end is called as hydrophilic end. Means what is the meaning of hydrophobic? This end does not mix with water usually, readily, and this end can mix with water readily. Now what we are going to do, if we are taking a oil drop on our clothes, how to wash the clothes? That is grease or any stain is there on our cloth. What we are doing? We are applying the soap. What is going to be formed? Hydrophilic and what is there? That is mixed with the water and attached to the grease stain. Attached to the stain. Now so many particles are mixing like this. One end means hydrophilic end is mixed with this. They are forming this type of, all these are another end, Na plus end, hydrophobic end. This is not mixed with water like this. This formation is called as a micelle formation. Now, by applying the soap on the stain, we will get this missile formation. When we are washing, this will go out along with the stain. That is called as cleaning action of soap. Cleaning action of soap. This is the way we discussed about carbon and its compounds. Very few bits we will discuss now. Okay. Now, what is the chemical bond in C2H2? C2H2 means I already told you H with one, but not satisfied, so 3 bonds. So 1, 2, 3, 3 sigma bonds, 2 pi bonds. Where is that? Right. And CCl3CH2 CHO. Very important one. Cl CH2 CH1. Numbering obviously 1, 2, 3. First substituent name, 3 chlorines are there on same carbon. 3, 3, 3 trichloro propanol. Propanol. Which one? This one. 3, 3, 3 trichloropropanol. This is propanol, means alcohol. Not true. Next. What is the general formula of ester? Ester. This is ether. This is ketone. This is ester. This is aldehyde. Next. What is the hardest form of allotrope of carbon? Diamond. That's all. That is carbon and its compounds. Sorry, I forgot this one. Which of the following is a saturated hydrocarbon? Saturated, this is for alkene, alkyne. Alkane is CnH2n plus 2, that we are calling as saturated hydrocarbon.